So in this video, we're going to wrap up Chapter 1 and wrap up our review of hopefully familiar topics by talking about circles. Okay, lines and circles, those are both elements of Euclidean geometry which are very, very fundamental to the geometric system. And I think all of us know what a circle is, or intuitively what it is. And when the ancient Greeks, when they set out to define a circle, they didn't define it as a set of points that satisfies a certain equation. They took a very basic geometric approach and said a circle is a set of points that are a fixed distance from a fixed point, right? And again, that's one of the axioms of Euclidean geometry, that you can do this. The fixed distance. So if we, a circle is basically determined by its center, which is the fixed point, and its radius, which is this fixed distance, right? So the circle consists of all points x, y, that have distance r from this fixed point hk. And now we can use what our distance formula to describe an equation that describes this circle. So remember, r is the distance between these 2 points. Okay, so if we use the distance formula, that's going to be x minus h squared plus y minus k squared. If I add them together, take the square root. So this basically says that r is the distance between these 2 points. And because we don't really like square roots too much, or they clutter things up, we can square both sides, and that doesn't change anything, and the square roots will go away. And so we get r squared is equal to this squared plus this squared, and we can just switch this around, and we get this is the standard form of the equation of a circle. So we have x minus h squared plus y minus k squared is equal to r squared. And it's important that you just remember that this constant over here, when it says it's not the radius, it's the square of the radius. Okay. So if we wanted to find the equation of a circle with center 1 or negative 1, 2 and radius 3, this tells us that h equals negative 1 and k is 2 and r is 3. So we just substitute in here, and we get x minus negative 1 squared plus y minus 2 squared is equal to 3 squared. Okay, and we can just say these cancel, and we get x plus 1 squared plus y minus 2 squared equals 9. And we don't want, we just leave it like this. We could multiply this out, but we don't really need to. In fact, I don't want you to do this. If we multiply this out, it would no longer be in the standard form. So we just leave it like this. We go in the other direction. If we have an equation like this, and let's say we want to sketch the graph of this equation, we can go in the other direction and see that, well, what's the center, what's the radius? Well, we have something in the form of x minus h squared plus y minus k squared is equal to r squared. Well, we can see that r squared is going to be 16, so r is 4. Now, we don't have a minus here, we have a plus, but remember, we can rewrite this as we can write x plus 3 as x minus negative 3, and we can rewrite y plus 2 as y minus negative 2. Okay, and so we can see that h is negative 3, k is negative 2. Okay, so our center is negative 3, negative 2. Okay, and then we can just plot this center, negative 3, negative 2. So there's our center, and our radius is going to be 4. So we can, well, all we need is a couple points on the circle. So we can go up 4 units from here. 1, 2, 3, 4. Go 4 units in this direction. 1, 2, 3, 4. 1, 2, 3, 4, 4. So it's going to be something like this. Okay, and it's not a very nice circle the way I draw it, but that's supposedly a circle. Okay, so that's how we would do that. And on a test or a quiz or something, I'm going to be much more interested in you being able to identify the center and radius rather than your artwork. Okay, some other problems you might see on your homework. We can find the center and radius, but I might also ask for the X and Y-Intercepts, and we know how to do that from other lectures or videos. First, let's look at this. Now, this equation is going to be a little bit different because we have these 3's here. Okay, and if you look at it in the general form, we want something in the form of, x minus h squared plus y minus k squared equals r squared, right? So we want to get rid of these 3's. And fortunately, because we have a 3 here and a 3 here, we can just divide everything by 3. Okay, and so we get x plus 1 squared plus y minus 1 squared equals 2. Okay. And so this is x minus negative 1. Okay, so we can see that h is negative 1, k is 1, and r squared is going to be 2. And, well, what does r have to be? We'll take the square root of both sides, and that means that r has to be the square root of 2. Okay, yes, we will be dealing with square roots in this class. Okay. All right. So our center is the point negative 1, 1, and the radius is the square root of 2. And then to find the x and y-intercepts, remember to find the x-intercept, we set y equals 0. So what we get is 3 times x plus 1 squared plus 3 times 0 minus 1 squared equals 6. That was our original equation. I guess we could have also just plug that in here. Either way, we get x plus 1 squared plus 0 minus 1 squared equals 2. Okay, that's what we get. And negative 1 squared is 1, so this is going to be x plus 1 squared plus 1 equals 2. We can subtract 1 from both sides. And we get x plus 1 squared equals 1. Now we could get we could multiply this out, but we don't want to, because we can see that this means x plus 1 is a number, whether if you square we get 1. So that means x plus 1 has to either be 1 or negative 1. Okay, so this would mean that x is 0 or x equals negative 2. Okay, so we would get 0, 0, and negative 2, 0. Those would be the x-intercepts. All right, and then for the y-intercept, maybe I'll let you work on this for a moment. Pause the video and work this out. You want to set x equals 0 in this case. Okay, so going back right up here, we get 0 plus 1 squared plus y minus 1 squared equals 2. This will be 1 plus y minus 1 squared equals 2. So y minus 1 squared equals 1. So y minus 1 is going to be similarly as before. Y minus 1 is either 1 or y minus 1 equals negative 1. So y is equal to 2 or y equals 0. So then we get 0, 2, and 0, 0. Okay, and you'll see that and these are the y-intercepts. And of course, this also means that 0, 0 is on both axes, so it'll be, we know it was going to be a y-intercept and an x-intercept. Okay. The next example, let's say we want to find the equation of the circle with endpoints of the diameter being these 2 points right here. Okay. Well, we could plot these 2 points and see what we're looking at if we wanted to. We don't have to do it that way. And in fact, you probably won't get a whole lot from drawing this. We can see that our circle is going to look like this, but we can't see exactly what the center and the the radius would be. But we can, because we know that the diameter is 1/2 the radius, and the diameter is going to be the distance between these 2 points. Okay, and then for that we can use the distance formula. So the diameter is going to be the distance between these 2 points. So that's 2 minus 4. So let's make sure we do this right. Okay, so this is going to be -3 minus 1 is quantity squared, and then we have 2 minus 4 quantity squared. Okay. So this is going to be -4 squared plus -2 squared. So this will be 16 plus 4, so this will be the square root of 20. Okay, that's the diameter. So the radius is going to be, oops,